Fascinating.
So our availability overlay was triggered by the bug menu through this checkbox. So just to remind ourselves briefly, when we looked at that, we were adding a widget by if the checkbox state is true, add the widget, saving it locally and adding it to the viewport. So that's kind of standard, simple widget being added to the viewport. And then when it's set to false, the checkbox unchecked, the reference that we have now locally to that widget, we are removing from parent. We are removing it from the viewport. So that triggers the interaction. But let's have a look at availability HUD and see what's going on in there. So you'll note that it's just a canvas panel set to the screen size that we want. And there's nothing else in there. There's no other components in the hierarchy here because we're doing it all in the graph. So this is, in effect, a parent widget. So same old trick, we're creating a reference to self and saving it into the game instance just so that we can access it easily should we need to at any point. And now this is where we are enacting a few bits of blueprint script to be able to populate this parent widget with child widgets. So what happens? So on event construct, when we are creating the availability HUD widget, we are searching the world using our get all actors of class to see how many of those markers are in the world. And we're returning those and saving them into an array so that we've got them as a full set reference and we don't have to use get all actors of class again. And for each of those three markers, we are adding a child widget to the parent canvas. So this canvas is part of this widget. So here we are, canvas panel, availability parent. So we are creating them and then adding child to canvas, and the target being this widget and adding them in. I'm also then just saving out each instance, of which we have 3 on this occasion, into a canvas slot setup array and also a crosshairs array, just because we need the reference to the canvas slot later on to be able to update it on tick and change the position of the widget in relation to the 3D world location. So another thing you may have noticed, obviously we exposed those variables on the actor that was in our world, but our child widget also has some variables exposed, and we're effectively using availability HUD, this widget and this graph, as a conduit to pass information from the actor in the world to our child widget. So I'm accessing the annotation and passing it into annotation. I've just named them the same for sanity's sake. And now all that kind of heavy lifting of moving that data that was instance editable in the actor has now been put into each of the created widgets on a per instance basis. So all that information has passed across. Now, on tick is every frame. So we're using tick to recalculate the 3D world position back to a 2D screen position. So looking at our array, we obviously have all our 3 widgets in the current state, 3 widgets in our array. And for each of those, we are finding the world location in our 3D map and then projecting that to a screen X and Y position. So this node is very powerful. It translates 3D to 2D. If you're wanting to go the other way, you deproject world. You deproject widget position to world location. There's another node that works the other way. So this translation is happening on tick. It's happening on every frame. So as the user is navigating and moving around the world, obviously the marker's position in in 3D is changing. So it's being refreshed and updated here, and the crosshair child widgets are updating in response to those changes. One thing that you will note here, there's kind of an extra piece of code. Now, the reason I put this in is when I've got lots of child widgets on screen, and if I turn my back on the locations of all the actors, the widgets are still on screen, but they seem to congregate up here in the corner, and it looks like an error. It looks like that they've all kind of crashed into the corner. So I'm saying here, basically, if any of the child widgets are in that corner under 2 pixels by X and Y, so very much in the corner, if both of those states are true, then just hide the widgets. So we're not getting that kind of build up of widgets in the corner. Okay, so let's have a look at our child widget. So what do we have in here? So we have a text block, which is linked to a function. So we know how that all works now. We have our variable, which is exposed and instance editable, being passed into the return node, thereby updating this text block when that variable is updated. Now, one thing you'll note is that text block is within a button that wraps around it neatly. Now, make sure you have size to content checked so that if the text changes, the button will update as well. If you have that off, the button will just be whatever size you've determined it to be. So turning that on will scale with the content. Okay, other variables that we have here. So I've got this one attributed to an animation, just the render opacity. This is the description text, which at the moment just has lorem ipsum in. But again, that is linked through a binding and relies on this descriptor string, which is instance editable and exposed on spawn. So all kind of familiar territory. So what about the interaction? Let's have a look. So we have our button, and we've got 3 interactions here. We have on hover, on unhover, and on clicked. So let's have a look at on hovered. So when the widget is first created, event construct, I'm hiding that description text just to make sure that it isn't visible at the very beginning. And then on hovered, if I'm hovering over that button, it sets the visibility, but the animation from the first frame. So in effect, it turns visibility of the description text block on, but because it starts from frame 1, it's invisible initially until it plays through the animation. And then on unhover, I'm just setting that descriptive text to hidden again. So that's the kind of basic interaction. We've got a bit more interaction here. This is the effect that the rollover has on outlining the linked static mesh that we connected from our marker actor in the world. So because we've been passing through our annotation and our description. Now, the annotation, if you recall, that was in the world marker to begin with. We've pulled it through into our availability HUD, using that as a conduit to populate this crosshair. But then again, I've then used the same reference to update on click, which is the final interaction. So when we clicked, we were creating a detailed widget which came on screen and pulled in that annotation information. So that was the unit number and the availability. So that gets pulled in and then added into our details widget. So let's have a look at our details widget. So in here, I've just created bindings for this text block and this caption block. And the bindings are the text itself in terms of the value of the text. So this is where that annotation variable gets used again, but now kind of chaining through from the world actor to the child widget, and now we're passing through the information again onto this widget. And then I've also created a binding for the color, so the color it gets rendered in, because this detailed widget is used in different contexts. So we use the green for our availability, and we use a kind of coral pink for facilities. So by having that variable, the render color of that text exposed and instance editable in the graph, here as a slate color, when we are creating it, again, we can affect the color of it. So in my game instance, I've set up some master colors. So you'll see that for availability, I have my kind of Tiffany green, and for facilities, I have this kind of coral pink. So now, depending on where my widget is being created, and in this case we're using availability, I'm passing the availability slate color through. Now I have done exactly the same, what we're looking at in terms of availability, I've done almost exactly the same thing for facilities, with one variation which I'll go into in another video in this series. But the point being is that we can have the kind of visual effect over the aesthetics as well as the content by exposing variables and pulling in our kind of preference from wherever we store those preferences. So in my case, I've stored them in my favorite place, which is the game instance.
Live long and prosper.